Hello and welcome, everybody. Happy Monday. Welcome to math class. Let's get started right away. We're talking about tenths and hundredths today. We've been talking a lot about fractions. We're going to dig in on these two particular fractions today. You're going to need something to write on, something to write with, and our icons are right down here. I can understand that 1/10 is equivalent to 1 divided by 10, and 1/100th is equivalent to 1/10 divided by 10. Let's get right into it. The first thing we want to talk about is a little bit of a review of our place value of whole numbers, because we haven't really talked about these in depth in a while. So I've got a big giant number here. Our number is 1,111,111. What happens if you put a 1 in every single place up to the millions place? And the reason that we're starting with this is we're reintroducing this idea where our place value system is built on groups of 10 or base 10. Okay, so meaning this 1 is really equal to, 1 times 1. This one's equal to 1 times 10, right? One group of 10. Okay, this digit's equal to 10 times 10, taking the value of the place 1 to the right, multiplying it by 10 to move it over to the left. 10 groups of 100, or 100 groups of 10, would be here, right? And so on. This would be 1,000 times 10. This would be 10,000 times 10. And then here we've got 100,000, or this place, times 10. Okay, so every time, I'll scoot this a little closer, every time we move one place to the right, or excuse me, to the left, we are multiplying by 10. Now, multiplication and division are what we call inverse operations, meaning they do the opposite thing, just like addition and subtraction. Addition adds more, subtraction takes away. Okay? Multiplication makes more groups, more equal groups. Division takes a quantity and divides it into equal groups. So, if when we move to the left, we're multiplying by 10, what happens if we move down to the right? We're dividing by 10. So if we were to erase all of these and think about our 1 million over here, this would be 1 million. Okay. Moving one place to the right, this value is 100,000. It's a 1 in the 100,000s place. Or we can think about it as it's 1 million divided by 10. Okay, we take our million M&Ms, it's a lot of M&Ms, divided into 10 equal groups. There's going to be 100,000 in each group. Okay? Likewise, on down, taking our 100,000, dividing it by 10 to get 10,000 in our 10,000s place. Keep going. 10,000 divided by 10 is going to get 1,000. 1,000 divided by 10 is 100. Okay, if I have $1,000 and I put it in 10 equal groups, I've got $100 in each group, right? 100 divided by 10 is 10. And then 10 divided by 10 equals 1. Now, if we follow this pattern, what would come next if we're going 10,000 divided by 10, 1,000 divided by 10, 100 divided by 10, 10 divided by 10? What would come next in this pattern? If you said 1, the value here, divided by 10, you'd be absolutely right. The next place in our place value system is going to be the tenths place. Okay, and we're going to get to that when we dig into decimals in the coming weeks. Okay, but for now, we want to know that when we're dealing with groups of 10 in our big whole number place value system, this is where tenths and hundredths as a fraction get really, really useful. Because if we think about 1/10, let me erase here. If we think about 1/10, if we think about dividing something into tenths, right? We have 10 equal pieces. Okay, each of them has a value of a tenth. If I add up 10 tenths, that gives us our whole 1. Okay? So tenths are really useful because, again, it's a fraction, but we're dividing it into 10 equal parts, just like our whole numbers do. You know, we take 10, divide it into 10 ones. Take 100, divide it into 10 tens. Okay? So tenths are going to be really useful. And likewise, hundredths are going to be useful. All we're doing with hundredths is we're taking 1/10 and we're dividing that into 10 equal pieces. Okay? Just like with 1/10, we're taking 1 and dividing it by 10. Okay, so this is where tenths and hundredths are going to be huge. So we're going to get comfortable with tenths and hundredths. Okay? To give you a little bit of a visual for tenths and hundredths, right? So let's say we have, here's our 1, right? So this whole thing equals 1. Maybe that's 1 square foot, let's say. Well, you can't see that. There it is. The whole thing equals 1, right? So let's say we're going to divide this 1 into 10 equal pieces. Okay? Divided it into 10 equal pieces, and each of these pieces has the value of 1/10. I hope that's 10 of them. Looks right. Yep. So then when you add up, we'll scoot all the way in here. When you add up those tenths, you end up with 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. Okay? Which equals 1. Now, let's look at our 1/100th equals 1/10 divided by 10. So let's take our 1/10, each of our 1/10ths, divide them into 10 equal pieces. 1, 2, 3, 9, 10. Okay? And if you look, each of our columns, each of our tenths columns, if we just look at, let me grab my blue here. If we just look at, I know I'm like picking the computer up so you can see it close. Let's just look at one of our tenths. And that's divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. Essentially, we've taken our tenths and divided them into tenths. Now, let's think about how many pieces did we divide the whole 1 into? Okay, 10 this way, 10 this way. It's an area model. 10 times 10 is 100. We've created 100 of these little mini squares. Therefore, because we've taken 1 and divided it into 100 equal pieces, the value of each piece is 1/100th. So if you add up all 100 of them, 100 1/100ths, well, that's an equivalent of 1 because the numerator and denominator are the same. So, again, tenths and hundredths, we're really just making groups of 10. Groups of 10, groups of 10, groups of 10. What if you took 1/100th and you divided it into 10 equal pieces? My gosh. What might happen then? What's 100 times 10? Let's try a couple practice problems here on our whiteboard, our digital whiteboard. Okay? So let's say we had something like, turn my pen on here. Let's say something we had like 3/10 plus 4/10, right? We can add this together. Denominator stays the same. 3 plus 4 is 7. Right? Nothing new here. What if the denominators are different? Let's do 2/10 plus 5/100ths. Two tenths plus 5/100ths equals what? Tell you what, let's go back to our model up here for this, because I think that'll be useful. So we had 2/10. Need two hands to take the cap off the pen. We had 2/10 plus 5/100ths. So let's color in 2/10. And let's color in 5 extra hundredths. Okay. Did we change the size of our square at all? No, we haven't added any value. Did we change the size of the pieces? No, we're still in hundredths. Okay? But how many hundredths did we color in? How many hundredths are in this row? We divided this 1/10 into how many equal pieces to make hundredths? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 hundredths, 20 hundredths, and then 1, 22, 23, 24, 25. So our final answer to that becomes 25 hundredths. We have 25 pieces colored in, and there are 100 pieces total in our one square. Okay, so we've really zoomed in on that, just one whole thing. Okay, so our answer is 25 hundredths. Excuse me. Fat fingers, I clicked the wrong thing there. So our answer is 25 hundredths. But wait a minute. Our denominators aren't the same. So how could we add them? We've got to turn those tenths into hundredths, don't we? So what equivalent of 1 would we use to make these tenths into hundredths? 10 times what equals 100? Well, we already demonstrated that in our model. It's 10. And we want to multiply by our equivalent of 1, so we're going to use 10 tenths. 10 times 10 is 100. 2 times 10 is 20. And look at that. 20 hundredths plus 5 hundredths equals 25 hundredths. Straight away. The nice thing about tenths and hundredths is it follows the same principle as whole numbers and tens and hundreds, right? Every time you add a 0, you're multiplying by 10. Okay, in the case of fractions, when you multiply by 10, you're actually multiplying the denominator by 10 as well. So you're cutting your whatever fraction you have or whatever quantity you have into 10 equal pieces. Okay, so if we had, let's do some practice with that. Let's say we had 6 tenths equals how many hundredths? Right? take your numerator, add a 0. 6/10 equals 60 hundredths. 9/10 equals 90 hundredths. Right? 1/10 equals 10 hundredths. Okay, and we can see that on our model. If I go back to the model here, we can see each of these tenths, each of these columns of tenths, they're broken into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. And total in our whole one, there's 100 pieces. So 10 hundredths is in each one of these tenths. Okay? Let's try one more. I'll have you try it on your own here. Let's go with 32 hundredths plus 28, no, I want something in tenths, sorry. 32 hundredths plus 5 tenths. Okay, so think about, make your denominators the same if you have tenths and hundredths. Right, the quickest fix for that, just add a 0 top and bottom to your tenths because you're multiplying by 10 tenths. I'm going to pause and go slow for this bit because it can be, I feel like I'm saying tenths and hundredths so much that the words are starting to lose all meaning. Okay, so just be aware. When you have tenths, whenever you got any quantity of tenths, okay, adding a 0 or putting a 0 on the end of your numerator and your denominator is the same thing as multiplying by 10 tenths or multiplying by 1. So it doesn't change the value. So then we have 32 hundredths plus 50 hundredths. Denominator stays the same when we add 32 plus 50. (82 hundredths). Okay. Now this fraction can be reduced because you can divide both of these by 2, but we're going to leave it as is. Okay, we're actually going to leave all of our work as tenths or hundredths today, just because I want to get us into the habit of thinking in tenths and thinking in hundredths. Because what's going to happen is once we get to really incorporating this thinking into decimals and incorporating it into our whole number place value, we're still going to call it 5 tenths, even though it's equivalent to a half. Okay, because it's going to look, there's no way to, when we're working in base 10, we're not going to reduce something to 1/2 or 1/4, okay, in decimal form. Okay, so we're going to leave it as 82 hundredths. All right, try one more. Let's do 6 tenths plus, actually, hello. 6 tenths minus 16 hundredths. Okay, make your denominators match and then subtract. Right, so we've multiplied by 10 tenths, making 60 hundredths. Now subtract. Denominator stays the same. 60 minus 16, or 60 minus 10, equals 50. And then 50 minus 6, 44. hundredths. So the big takeaway from this lesson is that with tenths and with hundredths, it's really a similar structure to the way we think about whole numbers. Okay, when you have 10 of a group, moves to the next place to the left. Okay, if you need to decompose a group, it's 10 of whatever place to the right, right? So if you're decomposing 1, you're decomposing it into 10 tenths. If you're decomposing a tenth, you're decomposing it into 10 hundredths, and so on and so on. Right? Some of you already correctly identified that if you take a hundredth and you decompose it, you're decomposing it into 10 thousandths, right? Just like multiplying by 10 over 10. On the assignment, do we not reduce? No, you don't have to reduce. Every answer should be in tenths or in hundredths. Okay? If you notice that it can be reduced, notice it. You do not have to reduce it. All right. Good luck, everybody. Small group is opening at 11 o'clock if you have questions. Otherwise, good luck. Have a good lunch, and we will see you back here this afternoon for science.